What is Data Encryption Standard Symmetric Encryption Algorithm? The Data Encryption Standard Algorithm is a symmetric key block cipher created in the early 1970s by an IBM team and adopted by the National Institute of Standards and Technology, NIST. The algorithm takes the plain text in 64-bit blocks and converts them into ciphertext using 48-bit keys. Since it's a symmetric key algorithm, it employs the same key in both encrypting and decrypting the data. If it were an asymmetrical algorithm, it would use different keys for encryption and decryption. Let's learn the history of DES Symmetric Encryption Algorithm. DE depends on the Feistel block figure, called Lucifer, created in 1971 by IBM cryptography analyst Horst Feistel. DE utilizes 16 rounds of the Feistel structure, involving an alternate key for each round. DE turned into the supported government encryption standard in November 1976 and was accordingly reaffirmed as the norm in 1983, 1988, and 1999. DE's strength reached a conclusion in 2002, when the advanced encryption standard supplanted the DE encryption calculation as the acknowledged norm, following a public rivalry to track down a substitution. The NIST authoritatively pulled out FIPS 46-3, the 1999 reaffirmation, in May 2005, albeit triple DE, stays endorsed for delicate government data through 2030. Some key features affecting how DE works include the following. Block figure. The data encryption standard is a block figure, meaning a cryptographic key and calculation are applied to a block of information all the while instead of the slightest bit at a time. To scramble a plaintext message, DE bunches it into 64 cycle blocks. Each block is enciphered utilizing the mystery key into a 64-digit ciphertext through change and replacement. A few rounds of encryption. The DE interaction includes encoding multiple times. It can run in 4 unique modes, scrambling blocks separately or making each code block reliant upon every one of the past blocks. Unscrambling is basically the converse of encryption, following similar advances yet turning around the request in which the keys are applied. 64-bit key, E. DE utilizes a 64-bit key, but since 8 of those pieces are utilized for equality checks, the successful key length is just 56-bit. The encryption calculation produces 16 distinct 48-bit subkeys, one for every one of the 16 encryption adjusts. Subkeys are produced by choosing and permuting portions of the key as characterized by the DE calculation, replacement and permutation. The calculation characterizes groupings of substitution and change that the ciphertext goes through during the encryption cycle. Backward compatibility. Data encryption standard also provides this capability in some instances. The algorithm process breaks down into the following steps. First step. The process begins with a 64-bit plain text block getting handed over to an initial permutation, IP, function. Second step. The initial permutation, IP, is then performed on the plain text. Third step. The initial permutation, IP, creates 2 halves of the permuted block, referred to as left plain text, LPT, and right plain text, RPT. Fourth step. Each LPT and RPT goes through 16 rounds of the encryption process. Fifth step. The LPT and RPT are rejoined, and a final permutation, FB, is performed on the newly combined block. Sixth step. The result of this process produces the desired 64-bit ciphertext. Next, to better understand what is data encryption standard, let us learn the various modes of operation for data encryption standard. Data encryption standard modes of operation. Experts using DE have 5 different modes of operation to choose from. Electronic Codebook, ECB. Each 64-bit block is encrypted and decrypted independently. Cipher block chaining, CBC. Each 64-bit block depends on the previous one and uses an initialization vector, for output feedback, OFB. Much like CFB, except that the encryption algorithm input is the output from the preceding DE counter, CINR. Each plaintext block is EXO-read with an encrypted counter. The counter is then incremented for each subsequent block. That's all, I hope you learned something. Thank you.